Welcome to the Explainer. Today, we're putting on our detective hats and doing a literal autopsy on a single piece of network data. We're going to break down, byte by tiny byte, exactly how devices talk to each other across the vast expanse of the internet. It's an absolutely fascinating process, and we're going to make the whole shebang entirely visible. Think about it. You type a web address, hit enter, and boom, an entire invisible world springs into action in literal milliseconds. All this information is traveling across copper wires, fiber optics, and radio waves in the blink of an eye. But what's actually contained in that data? How does it know exactly where to go? And, how does that info get back to you securely? To answer those questions, here's our roadmap for today. First, we'll look at framing the physical envelope. Second, we'll dive into IP addresses and routing. Third, TCP connections and ports. And finally, the HTTP payload revealed. We're going to systematically unpack a real piece of captured data, layer by layer, almost exactly like opening a complex set of Russian nesting dolls. Now, to actually see these invisible layers, we need a pretty special magnifying glass. Enter Wireshark. It's a seriously powerful network protocol analyzer. It essentially lets us freeze time, grab a piece of information right out of thin air, and peer inside the data as it's flying by on the network. Okay, let's dive into this. Here is our specific scenario, our virtual crime scene, if you will, for today's autopsy. We're looking at a simplified network capture of a local device, specifically 192.168.1.101, reaching out to www.google.com. It's basically the universal heartbeat of network testing, right? Something you probably do dozens of times a day. But today, we're actually going to pause and look at exactly how this specific request is structured on the wire. All right, starting off with layer 1, framing the physical envelope. Think of data transmission kind of like our traditional postal service. Before a letter can cross the country, it needs a physical delivery truck to safely get it from your front door to the local post office. And this brilliantly illustrates just how compact this whole process really is. Our entire captured frame on the wire, it's a mere 74 bytes. That's exactly 592 bits of raw data. Every single thing we're about to look at in this explainer, the routing info, the physical addresses, the actual web request itself, is perfectly, tightly packed into those tiny 74 bytes. Crazy, right? So within those 74 bytes, the outermost shell is the Ethernet 2 header, and that's what houses our physical MAC addresses. You'll notice our source MAC, ending in 92AF, is handing off to the destination MAC, ending in A355. These are basically the physical license plates on those delivery trucks we just talked about. They make sure the data frame physically gets from the sender's network card to the immediate next physical hop on the local network. Peeling back that first nesting doll, we arrive at layer 2, IP addresses and routing. Now, what's really interesting here is the specific routing information. If layer 1 was the local delivery truck, this IP address layer is the final destination street address. We're using IPv4, routing from our internal 192.168.1.101 straight out to destination 173.194.72.100, which, fun fact, actually belongs to Google. This right here is the crucial set of coordinates the internet's core routers use to pass the data along, hopping across the globe to hit the correct server. And that brings us to layer 3, TCP connections and ports. So if the IP address got us to the right apartment building, the TCP port tells us exactly which door to knock on. Our local computer opened up a random temporary source port, 53560, but it's aiming for destination port 443. That specifically routes this as secure HTTPS traffic to the web server. Also, check out the sequence number of 1 and the acknowledgement number of 1. These numbers act like a really rigorous tracking and delivery system, making absolutely sure every single piece of the puzzle arrives reliably and in the exact order it was sent. Okay, moving to our final layer. Layer 4, the HTTP payload revealed. So the crucial point here is that everything we just discussed, the 74-byte physical Ethernet frame, the global IP routing coordinates, the meticulous TCP tracking and port delivery, all of those complex headers existed for one single simple reason, just to safely deliver this tiny HTTP GET request. This data payload is literally just our computer politely tapping on Google's door on port 443 and saying, "Hey, hello, can I please get a copy of your web page?"
Let's take a quick step back and review the brilliant structure we've discovered today. We started out on the physical wire with the frame and Ethernet header, our physical envelope. Then we moved deeper into the IP header, mapping out our logical journey across the web. Next, the TCP header ensured our secure door delivery to the right application using ports and sequences. And finally, tucked safely inside it all, the payload, our HTTP data. That step-by-step, structured breakdown, that is the true anatomy of a network packet.
Now, I should mention, our specific example today was truncated a bit to keep this explainer focused. But mastering this visibility, it's completely invaluable for complex network troubleshooting and deep data analysis. In a real-world capture environment, you'd be seeing additional protocol headers, specific connection flags, and advanced options flying by in real time. And we're talking about processing millions of these packets every single second. Which leaves us with something incredibly fascinating to chew on as we wrap up. We just spent this entire explainer dissecting a mere 74 bytes of structured data, generated by a single, tiny, simplified internet request from one device. If just one simple click creates all of this structured, multi-layered activity under the hood, what does the traffic of an entire massive enterprise network look like at any given second? Thank you so much for exploring the invisible world of data with me today. Stay curious, keep focusing on how things work, and I'll catch you in the next explainer.